Very good evening to one and all. Very good evening, Bharatra Singh, Vaishnavi PV, Mainaka. Very good evening. Thank you for your valuable time spending with us, pantechelearning. It is our 21st day of our masterclass. So today we are gonna see the protocols like AMBA protocols. So what are the on-chip protocol, off-chip protocol? Okay, Sai Kiran, hello, very good evening. Thank you for your presence. So today we are going to see the protocols. It is very important. Why? Because of by these protocols only the hardware will communicating with another hardware. Okay. So this is we are gonna see the communication protocols from on chip and off chip. Okay, we are gonna see both. So we are gonna see just introduction about on chip protocols, off chip protocols, AMBA bus protocols. Okay. So very good evening to one and all. Thank you for your presence. So let's wait for a few minutes and then we will start the session. Okay. So T Kristen, very good evening. Vaishnavi P, Suja, hi. Professor Bharatra Singh, very good evening. Thank you for your presence daily. So and then just a minute. Is no, my voice is clear. So I think just a minute. So if your voice is clear, can anyone respond in chat box? Is my voice is clear? If my voice is clear means just put S in chat box. Okay. So thank you, sir. Okay, thank you for your response, Saikran. So today we are going to see protocols. Let's wait for a few minutes and then we will start the session. Today we are going to see the only brief introduction about protocols. Okay, about AMBA protocols, AXI, APB, and then AHB, I2C. We already seen UART and I2C protocol. It is very mandatory basic protocol for off-chip communication. Okay, it is very basic protocol. So UART is also very basic protocol and also it is important. So it is an easy and also it is very basic protocol. UART, I2C, SPI. Okay. So I think I can start now. So before going to that, I will just recall what are the on-chip protocol, what is off-chip protocol. So there are two types of protocols we have in the VLSI kind of thing domain. So one is on-chip protocol, another one is off-chip protocol. So on-chip protocol is nothing but that kind of protocols we are using inside the chip. That by using that protocol only inside the we already seen something like blocks, a lot of blocks inside the inside the chip. For example, a example like a SOC, inside the SOC it having a lot of blocks. So to communicate between the one block to another block, we have to use on-chip protocol. So name itself it having the on-chip protocol to facilitate the communication within the boundaries of the chip, like a intra-chip communication. So there are examples like AMBA protocols. So AMBA is a standardized protocol for on-chip protocol. So like AXI, AHB, APB, these are the on-chip protocols are mandatory. Mainly we are using. So industry also using this kind of protocol only, like AMBA protocols for. So it is AMBA. So AMBA protocols are given by the ARM company. So ARM is one company. They are giving the standardized protocols for on-chip communications. Okay, and then another one we having is known as off-chip protocol. So off-chip protocols. So yesterday we seen like I2C, UART. These all things comes under the off-chip protocol. It is only used for making communication between peripheral devices with with the chip. So it is making the communication between the chip with the peripheral devices. So it is known as the off-chip protocols. So it handles the communication between the chip and external components like it is a inter-chip communication. And also these are examples of the off-chip protocols are I2C, UART, SPI, USB, PCI, Ethernet, and then another there are a lot of protocols we have in the off-chip protocol. Okay, MIPI protocol. So this all comes under the off-chip protocol. Okay, one which protocol are using for making communication with the peripheral means that protocol is known as off-chip protocol. So inside the chip we are gonna make some communication between the two blocks. So that protocol is known as the on-chip protocol. So there is a basic definition about on-chip protocol, off-chip protocol. Okay. So and then we are see 1B. So this example for the on-chip protocol designed for for an internal communication in SoC. So mostly SoC means system on chip. Inside the system on chip it having a uh, lot of blocks. So we are using some protocol inside the chip means that protocol is known as on-chip protocol. For example, AXI, APB, AMBA protocol, and then wishbone protocol kind of things. Okay. So and then this is example for the on-chip protocol. AMBA protocol is known as Advanced Microcontroller Bus Architecture. It is given by the ARM company. Okay, ARM company. So it is developed by the ARM for SoC. So sub protocol includes AHB, APB, AXI. So we are gonna see the AHB, APB protocol in this masterclass. So these two protocols are on-chip protocol we are using inside our SoC. Okay. So namely as AHB, APB. So it is it's like a UART protocol only, but there's some difference. So each and every protocol what we are doing means to make to make the communication very good and then there is no error. So for that we have to follow some protocol, standardized protocol, then only we can make the reliable communication between the two components. Okay, so that we have to follow the protocols, conditions, and then rules, ethics kind of thing. Okay, so we are gonna see in this masterclass AHB and APB protocol spec and then code and then SystemVerilog test bench architecture. We are gonna see in this 3D masterclass. Okay, and also this is this example protocol for on-chip protocol. So I will assume like this is one architecture of SoC. So it's like on black diagram. So you can see here UART is one device, timer, keypad, PIO. So and then high performance ARM. So this is a main controller ARM processor. Here we have in the ARM processor. So high bandwidth on-chip RAM. So it is a memory. So it's kind of on-chip RAM memory. So and then it is a direct memory access bus master, DMA. So high bandwidth external memory interface. So it's like a one kind of SoC. It's like a SoC kind of architecture. So it having the ARM processor, RAM, on-chip RAM, direct memory access, external memory interface. So and then these components like a RAM processor, on-chip RAM, direct memory access, external memory interface. These all blocks are working very fast. Why? Because of on-chip RAM. So RAM. So we are using why we are using RAM means it will execute, it will send the data very faster. That's why we are using RAM. So that this kind of blocks or this kind of processor, RAM, DMA, external memory interface are working very fastly. Okay, but here you can see here UART. So UART is slower than RAM operation. So UART needs less time. UART is a slow protocol, low bandwidth. So UART is slower than UART protocol is slower than any other protocol. And then timer, keypad, PIO, these all things, these all components, these all devices need low frequency, low speed, low bandwidth. So but here these all components are working with high frequency, high bandwidth. So you can't do direct communication between the high bandwidth with the low bandwidth. Okay, high clock frequency, low clock frequency. If you made connection between the high frequency device with low frequency device means definitely you will get the collision, you will get the bug, you will get the error, you will get the unknown values. Okay, unknown results. So we need some interconnection, or we need some communicator so to send the data between we need some device to make the communication with this will smoothly. So here we having the bridge. So here we having the bridge. So bridge, this is a bridge is kind of protocol also. So here this is a bridge. These bridges are used for making communication between the high clock frequency with low clock frequency devices. So it will make communication between them. So basically here also it will do some synchronizer the techniques like a FIFO buffer or any other clock synchronizer. So it we are having a lot of design engineers, they are having a lot of clock synchronizer techniques. So inside the bridge it having some techniques kind of things. It's kind of like means synchronizer techniques. So either it having the FIFO buffer. Okay, so we already seen the how the data transfer may happens with the different clock frequency. Means by using the FIFO buffer you can make the communication smoother. So here we having the APB protocol. So APB is some kind of comes under the AMBA protocol, AXI, APB, AHB. So these three protocols are used in the SOC. So APB is I am telling orally of working of APB protocol. APB is a slower protocol compared to the AXI, AHB. So AHB is a medium protocol. It is more faster than the APB, but less than AXI protocol. AXI protocol is high speed protocol, high frequency protocol. So AXI is a first, and then AHB, and then APB. So APB is a low speed, low frequency, low bandwidth protocol. So here I am using the AHB protocol. You can see here AHB. So you can't do direct communication between the AHB protocol with the APB protocol. And the time we are using APB. So here this bridge is act as a master. This APB devices act as a slave. So here in the AHB master, like ARM act as a master, this bridge act as a slave. So this is a kind of things. ARM processor act as a, for example, the ARM processor want to communicate with the UART. So ARM processor will send the data to UART. So we have the bridge. So for AHB protocol, master is ARM processor, slave is bridge. For APB protocol, master is bridge, and then slave is UART protocol. So this is how it is work. So we are gonna see the spec and then code for this logic in the upcoming classes. So it is a very simple. It's not a simple. So it is very complicated also. Why? Because of we are dealing with the clock domains. Okay. So there is a basic need knowledge of VLSI engineer. So if you want to enter into VLSI design verification field, means design verification or design engineer, like a front end part of your VLSI engineer, means you need to know all these protocols, all these architecture kind of thing. Okay. So kindly tell us, is there any AA based tool for 8051 microcontroller programming? AA based tool. So there is no AA based tool for, I think, as per my knowledge, there is no AA tool for 8051 microcontroller programming. Okay. So 8051, you have to know the assembly language, assembly code for that, for to dump the code, to write the code. Okay, for 8051 microcontroller. So I think there is no tool. Okay, and then good evening sounds very low. Okay, so okay, I will increase my volume. So and then so this example for the AXI protocol. So I will tell you this protocol difference in the end of the session. Okay. So and then this is AXI protocol. We already know that UART, I2C, SPA. These are the AXI protocols we having. So and then UART, we already see the UART protocol code, TX, RXI and baud rate. So this is a frame format of the UART protocol. We already seen the spec and the code of UART protocol. So one start bit, 8 data bit, 1 parity bit, and then 1 or 2 stop bit. So mostly we will do with 1 start bit, 8 data bit, 1 stop bit. Okay. So and then it is yesterday also we seen the I2C protocol code. So this is a framework for that, like a start condition, stop condition. The main thing is, while clock is high, the data line if changes from 1 to 0, like a high to low, it is a start condition. If it changes from 0 to 1, low to high, it's a stop condition. So the slave address, acknowledgement, read and write data, and then acknowledgement. So we already seen this frame format in the previous classes. Okay. So and then it's time for, if you guys are really interested, you can convert this masterclass into 1 month of internship. So these are the benefits you will get at the end of the 1 month of internship. All the details, recording sessions, PPTs, source code. You can also download that, and then IETE confirmation letter, and then you will get the 180 days of LMS course access. It's a literally 6 month. Okay. So and then you will receive the weekly live classes for your doubt clearing. So and then you will get the internship report. If you are studying in the college student means you will get the academic internship report for the internship. Okay. So and then finally you will receive the I valued IETE certificate. So it is a central government institute like IETE. So you will get the internship certificate from that IETE. Okay. So these benefits you will get at just discounted fee of just 999. So our regular fee is 499. In this masterclass period, we are providing discounted fee of just 999. By using this link, you will get the internship program, and also you will get the link in chat box also. Okay. So this is and then if you after clicking this link, you will see this window. Here you have to choose. Here you have to choose the course of advanced VLSI design and verification. Okay. So this is a sample certificate you will get at the end of the 1 month of internship. Okay. So this architecture I will show you. I will come to next. Before going to that, I will give the introduction about AMBA protocols. AMBA APB protocol. So you will receive the certificate. So you will receive the attendance link. So we are going to see the APB AMBA protocols. So I will share the link for my attendance and internship. Okay. I will share the link in chat box. Just a minute. So with the name of with the username of Manikandan Ayyappan, I will share the link. Just a minute. So I just share the link. I will share one by one for the attendance link and then payment internship link. Okay. So first link is for Google form for your attendance. So just copy the command and then paste in your browser. Okay. So we'll see the AMBA protocol. Okay. So AMBA is one protocol. It is only used for on-chip protocol. It is given by the company. The stands for the full form of AMBA is Advanced Microcontroller Bus Architecture. Okay. So it is only for on-chip protocol. It having the 3 kinds of protocols. Okay, 3 kinds of AMBA buses, AMBA protocol buses. They are AHB, ASP, APB, and another one is AXI also. So I will come with that again. So AHB is nothing but advanced high performance bus, and then APB is nothing but advanced peripheral bus. So and then ASP, advanced system bus. So ASP is a legacy protocol. It's like a old protocol, and then we are currently using the APB, AXI, AHB only. So AHB is a slower protocol, and then AHB is faster than APB, and then AXI is another protocol is known as AXI. It is also faster than AHB. So APB, AHB, AXI. Okay. So and then AHB protocol. We will see the firstly definition, basic intro about AHB protocol. So AMBA AHB is nothing but advanced high performance bus protocol. So it is a name itself, it having high performance. It means it is working based on the high clock frequency. Okay. So and then AHB acts as a high performance system backbone bus. So and then AHB supports the efficient connection of processors, on-chip memories and off-chip external memories, and then low power peripherals. Okay. So and then coming to the APB. So APB is nothing but advanced peripheral bus protocol. Okay. It is only used for communicating between the low speed devices with the high speed devices. It will make communication within the low speed. Like it means it is using the low clock frequency. So the name is it having the advanced peripheral bus. So peripheral means it is definitely working the low frequency only. Okay, so it is only used for the low frequency devices. Okay, so not devices, low frequency blocks inside the chip. So and then AMBA APB is optimized for minimal power consumption and reduced interface complexity to support the peripheral functions. APB can be used in the conjunction with either version of system bus. It means so we can by using the APB signal, you can make the connection between the AHB and the APB. So I already said no bridge. The bridge is nothing but APB master, AHB slave. So and then this is a basic thing of the bus cycle, bus transfer, burst operation. So burst is nothing but collection of byte is known as burst. So this kind of things we will discuss in upcoming classes. Why? Because of each and every protocol differ from the bus cycle, bus transfer, bus operation. Why? Because of bus cycle. So bus cycle is nothing but so for one data transfer, that protocol it takes how many cycles. For example, while dealing with the UART protocol, to send the one bit of data to receiver means you have to wait for that particular clocks per bit count, like through 434 count, 434 at each every 434 clock cycle only you can send the data to receiver in the UART protocol. Same thing. So in one clock cycle, how many bits? So far to send the data from master to slave by using the one protocol, for sending the one data, how many cycles are needed. Okay, so this kind of clock cycle counts differ by the protocols. So APB need 2 clock cycle to send the data from master to slave, but AHB APB are send the data in 1 clock cycle. Okay, so APB protocol needs 2 clock cycle, like a first clock 1 passage to second passage. So totally it need 2 whole clock cycle to send the data from master to slave. But in the AHB APB, they AXI AHB, that 2 protocols need only one clock cycle to send the data from master to slave. So and then bus transfer. So there are a lot of transfer in the bus, like a lot of internal things. Like a bus transfer is nothing but APB don't have any bus transfer, but AXI AHB are having the bus transfer. So whether there are variety of types of bus transfer, we will see in the upcoming classes. So like this bus transfer, like a read or write operation of data object. So but in the APB we don't have any bus transfers. So you can see here APB transfer read or write operations of update data, which always requires 2 clock cycles. So APB protocol requires 2 clock cycle to send or receive the data from master or receiver, master or slave. So and then burst operation. So there is no burst operation in APB protocol, but in the AHB AXI protocol there is a burst operation. So burst is nothing but collection of packets, in one packet. So collection of bytes. So 4 byte is known as one burst. So this kind of burst transfer are in the AMBA protocols in the AXI and then AHB protocol. So this is a main basic thing, like a bus cycle, bus transfer, bus operation of protocols. So and then coming to the AMBA block diagram. So this is a block diagram of AMBA block diagram. It's like you can see here same a bridge here, AHB, high bandwidth. So this we already seen this. So this is a basic example for the AMBA protocol, how it is using. So and then this is a difference between this usage of the AMBA protocols. AHB is high performance pipeline operation. So pipeline is nothing but, so in the low time of the clock, that the address will be sent. In the high time of the clock, the data will be sent. So in the 1 clock cycle, it will do the pipelining. So it will do the pipeline operation, and at the same time it will start multiple operations to send the data. So it is known as the pipeline operation. So and then multiple bus master and then bus transfer, split transaction. This is the advantage of the AHB. So and then ASP, high performance bus, and then pipeline operation, and then multi-bus master. So and then coming to the APB is a low power single interface suitable for the many peripherals. So these are signals. So coming to the, we have these signals are so each and every protocol having the separate signal names, like a, so it having some indications. The P is refers to APB signal, P clock. P clock is nothing but APB clock. So why we have to indicate, why we have to give the separate name of this protocol means, so inside the SOC we are gonna write all the blocks code, Verilog code, we are gonna write all the design code. So we are using, we have to use all the protocols like AHB protocol, APB protocol, AXI protocol. So each and every protocol having the same signal, like a clock reset is a default signal for all the protocols. So if we, without any declaration, without any indication for the respective clock means respective protocol means, there is maybe confusion, there is maybe will happen the confusion. Why? Because of APB protocol having the clock and also AHB protocol having the clock signal. Both signal names are same, like a clock, CLK. So you don't know this clock comes from which block, which protocol. Then this clock which comes from which protocol. We don't know that. To neglect that confusion, we are using the indications, prefix indication. This P is refers to APB, okay, APB protocol. And then same time and then AHB having the H indication, H prefix. H is refers to the AHB protocol, A is refers to the AXI protocol. So these kind of protocol, APB protocol signals, I will say one by one in the upcoming classes. So tomorrow also we will start with the APB protocol, and on the time we will start this basic information very clearly. So and then, so it having some states. So every protocol having the FSM, like so we know that I2C having the start condition, start state, address state, acknowledgement state, data state, acknowledgement state, stop state. Same thing, the FSM in the every protocol we have in the FSM. So in the APB we have the ideal setup access. Okay. So this kind of waveform diagram and then signals we will see in the upcoming classes. Why? Because of each and every protocol very important. So it will make big changes in the design. So we will see one by one in the upcoming classes. And then there is no time for now today to cover all the spec. So I will just show you the difference between the AMBA protocols. AMBA protocols we have in the three: AXI, APB, AHB. APB is a low speed, AHB is a higher speed than APB, AXI is higher speed than AHB. Okay. So the names are Advanced Peripheral Bus Protocol, Advanced High Performance Bus Protocol, Advanced Extensible Interface AXI. Okay. So you can see here APB is a low power consumption, AHB is a more power consumption than APB and less power consumption than AXI. So and then AXI is a more power consumption than AHB and then APB. So APB, so it is used to interface any peripherals which are the low bandwidth, but here it is used for any peripherals and memories. Like a memory means, so in the if you are communicating between the controller with memory means, the controller will fetch the data from memory to controller. The controller needs the data from memory. So it means memory will send the data very fastly. So that we are using the APB. So AHB. APB is a slower protocol, low bandwidth, but here AHB is a high performance protocol, high speed protocol. So same thing. So AXI is a more speeder than AHB. So AXI is a point-to-point interconnect that designed for high performance, high speed microcontroller system. Okay. So and then in APB is a not pipelined, but AHB, AXI are pipelined. So and then APB is a simple. So AHB is a complex protocol than APB. So and then AXI is a very complex than APB and also AHB. So and then quality of service. So APB does not support the quality of service, but here AHB, AXI provide the quality of service. So and then write stop and then the write stop. So these all things comes under the protocol information. So these write, stop, read, stop. So these all things we will discuss in upcoming classes. So and then lock code transfer, support lock code, and then lock code transfer. The APB don't have any lock code transfer, but in the AXI only having the lock code transfer, but AHB also don't have any lock code transfer. So I will discuss with things lock code transfer, unlocked transfer in the upcoming classes. Okay, and then APB does not support the exclusive transfer. AHB also does not support, and but AXI support the exclusive transfer. So and then there is no channel in the APB, and then AHB also there is no channel, but here in the AXI we have in the 5 channel. So 5 channel is nothing but read channel, write channel, and then there are 5 channels like read, write back, read back kind of thing. So read address, write address, and then slave response from slave response to master. So these are all the channels we have in the AXI. One for the read or write. So totally we will do the read and write from the address and then data. So read address, write address, read data, write data, and then response. So response channel. So totally we are having the 5 channel in the AXI protocols. So in the write channel, in the write address channel, we can send the address data. So I means write address data. So in the write data channel means, write address, read data. So write address, read address, and then write data, read data, and a response channel. So response means slaves are telling something to master. So this is a response channel. So this is the basic definition of the protocols. So basic definition of the AMBA protocols. So in this masterclass we are going to see the APB protocol and also AHB protocol. In the upcoming classes we are going to see the definition, spec of the APB and then AHB protocols. Okay. So and then before this, I think this is for today. So main thing is today is very small session because of we are going to see only definitions of protocols. So this is for today. So and then another information is, so there is no classes from tomorrow to Tuesday. Okay, due to the Diwali celebration, Diwali holidays. So from tomorrow to Tuesday there is no classes, like 4 days, Saturday, Sunday, Monday, Tuesday. So there is no classes from tomorrow to Tuesday. Okay, from Saturday there is no class, Sunday also there is no class, Monday also there is no class. We will see the next class in the Wednesday. Okay, after the Diwali we will see that we will see the remaining topics, remaining classes. So and then this is for today. If you guys any doubt means you can ask now. So and then happy Diwali to one and all whoever watching this masterclass. Happy Diwali. Enjoy your days with holidays with the Diwali celebration. So if you guys any doubt means you can ask now. So there is no doubt. I think it's only for this class today. It's only for the protocols only. So what are the protocols? How it's working? So what are the functions of protocols? So why we need the protocols? Okay, just refer the AMBA protocols. It will be helpful for you. So whoever looking for the job in the VLSI domain, this is a basic protocol you must know, and then you have to thorough in these protocols. Okay, so and then so Radhika Krishna, I already shared the attendance link with the name of Manikandan Ayyappan in the chat box. So again I will share the link. Okay, so just copy paste in your browser. So I shared the link in chat box. Okay, try to use that. So thank you guys, thank you for listening. Happy Diwali. We'll see the next class on Wednesday next week. So thank you guys, thank you for listening.